Grid-forming STATCOM GFM is an advanced version of the traditional STATCOM static synchronous compensator used in power systems. It is equipped with grid-forming capabilities, which means it can not only inject or absorb reactive power but also provide voltage and frequency regulation to help stabilize the power grid during disturbances. GFM STATCOMs are important for ensuring grid stability in systems with a high penetration of renewable energy sources like solar and wind power, which tend to have lower system inertia. Key components and STATCOM functionality. A traditional STATCOM is a shunt-connected voltage source converter VSC that regulates voltage by providing or absorbing reactive power. Grid-forming functionality. The grid-forming aspect allows the STATCOM to control voltage and frequency autonomously, without depending on an external grid reference, essentially acting as a virtual synchronous generator VSG. Benefits: voltage and frequency regulation. A GFM STATCOM can provide voltage support by injecting or absorbing reactive power and can also manage frequency, which helps in maintaining grid stability. Black start capability. GFM STATCOMs can provide support for black start operations, restoring the grid without relying on external power sources by forming a stable voltage and frequency reference. High renewable integration. They are highly useful in grids with high penetration of renewable energy sources. As traditional synchronous generators are replaced by inverter-based resources IBRs, GFM STATCOMs can supply grid stability functions. Enhanced grid resilience. During grid disturbances, GFM STATCOMs contribute to system inertia and damp oscillations, providing a faster response to voltage and frequency deviations compared to traditional synchronous machines. Advantages: stability with low inertia grids. GFM STATCOMs can mimic the behavior of synchronous machines and provide virtual inertia, helping stabilize grids with a high share of renewable energy that lack traditional inertia. Faster response time. The inverter-based technology of GFM STATCOMs provides a faster dynamic response to voltage and frequency deviations, enhancing transient stability. Reduced harmonic distortion. By injecting high-quality, harmonics-free current, GFM STATCOMs can improve power quality in the grid. Flexible location. GFM STATCOMs can be installed anywhere in the grid, especially in remote or weak grid areas that are vulnerable to voltage instabilities. Black start capability. They provide voltage and frequency support without the need for external grid references, making them useful for black start scenarios. Disadvantages: high cost. GFM STATCOMs are more expensive than traditional reactive power compensation devices due to their advanced control and hardware components. Complex control systems. The control algorithms required to implement grid-forming functions are complex and need continuous monitoring and tuning.